Today we're going to make our very own artificial heart to learn about prosthesis as a new field of biomedical engineering. You're going to need one air inflation bulb, 2 clear vinyl tubes, 1 3-way T-connector, 2 gas check valves, 1 balloon, 1 small rubber band, 2 styrofoam bowls, and water to fill up one of the styrofoam bowls. First, lay out paper towels so as to make sure that your workspace does not get wet. Next, take the inflation bulb and the 2 check valves. Insert each check valve into either end of the inflation bulb, making sure that they are opposite of one another. The best way to test this is by pressing the inflation bulb. If you have done it correctly, air should go out of the right side. And if you put your finger over the left side, it should make the inflation bulb flat like a vacuum. Next, take the 2 tubes and attach them to either end of the inflation bulb. Make sure you attach them tightly or you will have leakage later on. Now, take the balloon, the T-connector, and a small rubber band. Put the end of the balloon over the very bottom of the T-connector. Then use the rubber band to attach it tightly. That way there will be no leakage. Now, attach the T-connector to the right side. The best way to make sure you have the correct side is by squeezing the bulb. Air should flow out of the right tube. Now take a styrofoam bowl of water and an empty bowl to catch the leakage. Put the left tube into the bowl of water. And make sure that the T-connector is higher than the water level and above the empty bowl to catch any drips. Now pump the inflation bulb until there is no air left in either of the tubes or the bulb or the balloon. Once that's happened, attach the left side to the T-connector. Make sure both sides are attached tightly. Now, press the bulb. We have a functioning artificial heart. This represents the blood moving out of the heart to the lungs and back to the heart again. So now we have 2 heart models and we're going to put them together into one circulatory system. Let's see, we have this one and this one. So what we're going to do is just make a whole circle out of them. So now we're going to attach each to the opposite until we have a full figure 8. Here. We have one complete circulatory system model. So now if I press these, it pumps the blood. This balloon right here is going to represent the body, and this represents the lungs. So basically what happens is the blood moves from the heart to the lungs. And the blood that moves from the heart to the lungs is deoxygenated, which means it does not have oxygen in it, which is why it's going to the lungs, because then the lungs will give it oxygen, making the blood that's coming out of the lungs oxygenated blood. Then this oxygenated blood is going to move to the body so that the body has oxygen. It's the body right here. Then the body's going to use it up, so it's going to come right back to the heart again, because now it's deoxygenated once again. It needs to go back to the lungs. And that's how you complete the circle. And there you see we have a full circulatory system. Pretty cool. What we've done today is basically go through the process that a biomedical engineer goes through when they try to come up with a prosthetic. We've tried to come as close as possible to the actual functionality of the original organ, which in this case was the heart. Alright, thanks for watching, and if you have any questions or comments, just comment below.